हेलो फ्रेंड्स, स्वागत है आपका मेरे चैनल में। आज मैं डिस्कस करने जा रहा हूँ लीटकोड डेली चैलेंज प्रॉब्लम। प्रॉब्लम नंबर इज 378 एंड द नेम इज kth smallest element in a sorted matrix. It's a medium level problem. Let's read the problem. Okay, we are given an n cross n matrix where each of the rows and columns is sorted in ascending order, and we have to return the kth smallest element in the matrix. Note that the kth smallest element in the sorted order, not the kth distinct element. Okay, we have to return the kth smallest element in the sorted order from the matrix, and we must find a solution with a memory capacity better than 1 square. Okay, they have given us a constraint that the memory capacity should be better than 1 square. Okay, so let's read out the first example: 1 5 9 10 11 13 12 13 15. Okay, and we have to find the kth smallest element, which is 8th smallest element. Okay, so see, 8th smallest element will be, so see, there are 3 into 3 9 elements. Okay, so the 9 element means the 9 smallest element will be the greatest element of the array. So greatest element will be 15, because we can see that no other element is greater than 15, and 9th smallest element is 15, and 8th smallest element will be less than 15. Okay, so it will be the next element is 13 only, so the 8th smallest element will be 13. Okay friends, so this is the approach. And if you see the second example, and it's given the matrix size. Matrix is of two dimension and it contains only one row and one column, and k equal to 1. We have to find the first smallest element, which is only the element that is there. So our output will be 5. Okay, so to do this question, let's proceed to the one notebook. Okay, I have written down the example. There are two approaches to do this question. Okay, so see, first approach will be, we can use a priority queue, and priority queue is by default the max heap, and we will maintain the max heap till the size equal to k, and whenever the size exceeds the k, we remove the element from the top. Okay, and at last we'll return the top element. So see, what I'm saying is that we'll maintain a priority queue. Let's says this. Okay, suppose this is our priority queue and will contain the kth smallest element. So we'll insert each and every element to the priority queue. So see, it will be 1 5, and we have the constraint that it's 8 smallest element, so I'm writing here 8. Okay, so see, 9 will be there. Next will be 10, then 11, then 12, 13, and 13. Okay, let's count the elements: 1 2 3 4 5 6 7 8. Okay, no problem. And next is the element which is 15, and we can see that this element 15, this element is greater than k, so it will be popped out from the priority queue. So we'll remove this element, and at last we'll return the, and it contains only the 8th element: 1 2 3 4 5 6 7 8. Okay, and we'll return the topmost element, which is 13. So our answer of the priority queue will be 13, which is the pq dot top. Okay, let's check out its code. The code is given in this. Let's see. Wait a second. Okay, this is our code. This code is the first approach that I have told you. We are using a priority queue. We'll iterate over the matrix. Okay, and we'll push each and every element to the matrix size, and if we see that the size is greater than k, then we'll pop from the priority queue, and at last we'll return the topmost element, which is the kth smallest element. Okay, so this is the approach that we have to do now. This this approach is good and will work on Leetcode, but it has a shortcoming that it uses the space which is O of k, and we can do some optimization so as to reduce this space to O of 1. Okay, let's check out this code. Let's check out this another approach so that we could reduce this space. Okay, as you know that in the wording of the question, it's given that the rows and columns are sorted, and whenever the word sorted comes in the play, we use binary search. We can think of a solution. We could use a binary search. So let's try to play the binary search on this question, and we will initialize the low will be 1 and high will be 15. Okay, let's name them here: low and high. Okay, so see, our low is 1 and high is 15. Now see, we'll apply the binary search. We will find the mid element. Mid element will be low plus high by 2, which is low plus high minus low by 2, which is 1 plus 15. 1 plus 15 is 16. 16 by 2 is 8. Okay, mid will be 8. Now see, we'll check what are the we'll check in this matrix what are the number of elements which are less than 8, and if we found the okay, let me add here k equal to 8. Okay, and if we found the number of elements which are less than the mid element that we got is equal to k, then we can surely say that this is the element that we are trying to achieve, means that it's the k smallest element, and if it's less than k means that we have found a greater element. Then we'll check in the uh, uh, other side of the mid. Okay, locals to mid plus 1. So what I'm writing is that to find the number of elements which are greater which are less than 8 is that we can use upper bound function. Okay, and it will return upper bound, and we have to subtract this from the first element so that we could get the count of the elements. So let's check out this approach. With what I have used there is that we will initialize the matrix dot size. Low will be the first element of the matrix, which is 1. Okay, and high will be the 15, which is the last element of the matrix, and minus 1 and minus 1, and we are iterating while low less than high. We'll searching for the mid element. We'll first find the mid equals to low plus high minus low by 2, and c equal to 0, which stores the count of the elements. And for each row we are traversing, we are checking what are the number of elements which are less than our mid element. Okay, and we are subtracting from matrix I dot begin so as to get the count of the elements. Okay, and if we see that the count is less than k, means that we have found a means that we have found a smaller element, then we'll traverse in the other half of the array, which is equal to mid plus 1, else we'll initialize high equal to mid, and at last our answer will be in the low pointer. So this is the approach. We can use this in the question to achieve this, and it will and we have optimized the space which is the first approach was using is O of k, and we have optimized this to O of 1. Thank you friends. If you like this solution useful, then like, share and subscribe to my channel. Please friends, show some love and like and share my channel.